Welcome back to the channel. This is the Earth Science Classroom. This video is on plate tectonics, and we're going to look at subduction, the definition of subduction, what is required for subduction to occur, and why it's so important and critical in the plate tectonic system. This is the Earth Science Classroom. Subduction is a part of plate tectonics, an overarching understanding and appreciation of the Earth's surface and how it's broken into pieces that are called plates. There are major plates, the large ones, there are smaller ones called minor, and in between there are tinier or smaller ones called microplates. And these all join together like a massive puzzle across the Earth's surface, and this includes the crust, which can be either oceanic or continental, and the lithosphere, which is the layer of the Earth's interior, which is directly below the crust and is part of the upper mantle. And we have the moho, which is the depth in which the crust turns into the upper mantle, or the lithosphere, which was found in 1909 through the change in velocity of seismic waves. So plate tectonics is really concerned with the surface of the Earth, the two top layers, and how they fit together and move across the Earth's surface. Now, subduction is a special feature that is integral to this plate tectonic system on the Earth's surface, and how it functions is critically important to understand. So subduction is involved with two tectonic or lithospheric plates that are converging, colliding, moving towards each other, and it's all based on various characteristics of those plates. First being the type of plate. Is it a continental plate or an oceanic plate? Why is that important? Because of each plate has their own characteristics, their own composition, density, and thickness and age. Oceanic plates or oceanic lithospheric plates are generally denser and composed of mostly basalt, which is an extrusive igneous rock with a density of around 3 grams per centimeter cubed. These plates are generally thinner compared to the continental plates that are much thicker, on average 25 to 35 kilometers thick. Oceanic plates are generally thinner, between 7 to 10 kilometers thick. And the continental is less dense, mostly composed of granitic rocks, around 2.7 grams per centimeter cubed. So the oceanic plate is denser. And when these two plates collide, when you have an oceanic plate as one of the two plates that are colliding, you get subduction. Subduction is where one plate is forced under the other plate due to gravity, density differences, and the action of the above plate guiding the heavier, denser plate underneath. And this is called underthrust. Now, subduction is where one plate, the denser plate, is going to subduct or sink or move under the lighter, less dense plate, which is technically going to float. Another characteristic of these two plates that can control or dictate the type of subduction is the velocity, the speed of motion of these plates as they're being pulled and moved by the convection currents that are in the asthenosphere, which is driving plate tectonics and driving all the plates' motion on the surface. Here we have a diagram looking at a convergent plate boundary between two plates, one being oceanic and one being continental. Now, this is a classic subduction zone where we have the oceanic plate contain both the crust and lithosphere, and it sits on the asthenosphere, which is moving through convection currents and the flow of both rocky material and magmatic material, so magma. And this conveyor belt, this flow of material, is actively dragging and pushing the above tectonic plate. In this case, it is the oceanic one, composed of basalt with a density of around 3 grams per centimeter cubed. And above that, we have the actual ocean. And you'll see that the oceanic plate is moving and subducting underneath the thicker and lighter continental plate, which is composed of a mix of mostly granite, maybe some andesite, or some diorite, but mostly granite with a density of 2.7 grams per centimeter cube. So it's lighter, less dense than the oceanic plate. So subduction is from the oceanic plate side, and it's being forced under through gravity and through the thickness and the density. And you'll see that you have an accretional wedge on the continental side, which means that the rocks that are being broken off through subduction are being transported and moved onto the side of the continent and forming a accretion and growing and building of that part of the continental crust. Then we also have the oceanic trench, which is formed through an increase in depth around the point of subduction, where the oceanic plate is being forced under the lighter, less dense continental crust. Then we have the addition of certain elements into the rocky material of the oceanic plate and the crust, involving water and hydroxyl ions, resulting in hydrous minerals being added into the subducting plate, which causes the rock to lower its melting point, meaning it melts quicker at a lower temperature. And as you add these elements into the subducting plate and the slab, it's going to allow what's called flux melting. It's going to melt quicker as it subducts, and this will form magma at a certain depth, around 25 to 40 kilometers, and this magma will rise up through the continental crust. This will mix and assimilate the magma as it rises up towards the surface, creating more granitic magma than originally basaltic magma, and it will then erupt through volcanic activity on the surface, creating a volcanic chain on the continental side. So we have certain features that are associated with subduction and subduction zones along these convergent plate boundaries, especially when you have oceanic plates colliding and subducting. So you have the ocean trench, you have the convection currents, you have flux melting, and you have parts of the subducting slab and the continental plate actually melting due to these hydrous minerals that will allow magma to be formed and rise to the surface, creating volcanic activity. In summary, subduction is where you have the denser plate in a convergent plate margin or boundary is forced under the lighter, other, less dense plate. Now, in most cases, it is an oceanic plate which is denser and therefore subducts under the other lighter plate. The other plate could be oceanic, most likely continental. Now, this is a very important geological and tectonic process or mechanism that occurs along this plate margin or plate boundary, forming various geological features on the surface. And it stimulates the rock cycle with the older subducting oceanic plate. Parts of it will melt and reform into magma and therefore go back into igneous rock when it cools. And the subduction acts as a way to destroy the older, thicker oceanic plate, whereby the subducting slab would travel and migrate under the lighter plate and continue down into greater depths within the asthenosphere and even to the core mantle boundary, as some research has indicated. The subduction zone also is part of the Wilson cycle, where you have the continuous opening and forming of ocean basins and the subsequent closing through subduction, closing of these ocean basins to form a supercontinent, the last one being Pangaea. This is the Earth Science Classroom. Thanks for watching the video. If you liked it, please subscribe, like, and share. And if you want more content and videos on Earth Science, please check out my channel.